You feel like you're sitting still right now, don't you? Maybe you're in a chair, on a couch, or lying in bed. The world around you feels solid, stable, unmoving. The floor isn't vibrating, the walls aren't shaking, you feel at rest. But this feeling, this deep, intuitive sense of stillness, is probably the biggest illusion you'll ever experience. It's a comforting lie whispered to us by our own limited senses. A lie that hides a truth so vast and dynamic it challenges our very place in the universe. Because while you feel stationary, you are, in reality, a passenger on a cosmic express train. You're hurtling through the infinite blackness of space in at least 5 different directions at once, at speeds so colossal they defy our everyday understanding. You're caught in a gravitational dance of unimaginable scale, a multi-layered journey that's been unfolding for billions of years and will continue for billions more. The true path of our Earth, our Sun, our entire solar system is a mind-bending, spiraling journey through the cosmos that is far more complex, far more dangerous, and far more beautiful than you were ever told. What if I told you that the simple circular orbit we learned in school is just the first tiny step in a performance of epic proportions? That our sun isn't a fixed anchor, but a golden chariot pulling its planetary family on a frantic race around a galaxy that is itself careening towards another? And that our entire galactic neighborhood is being pulled relentlessly toward a mysterious, unseen cosmic anomaly. The story of our motion is the story of, well, everything. It's a tale written in the language of gravity, speed, and time. And over the next few moments, we're going to peel back each layer of this cosmic onion, revealing the true, intricate, and absolutely astonishing way our solar system actually moves. The journey you've been on your entire life is about to be revealed. To understand this grand journey, we have to start at home. We start with the motions that are most familiar, the rhythms that define our days and our years. These are the first 2 layers of our cosmic voyage, the spin and the orbit. First up, the most intimate motion, Earth's own rotation. It's the gentle turn that gives us sunrise and sunset, the constant spin that creates our day and night. We don't feel it, but our planet is rotating on its axis at a serious speed. If you were standing at the equator, you'd be whipping through space at about 1,670 kilometers per hour. That's faster than the speed of sound. Think about that for a second. Right now, you're moving at supersonic speeds just by being on this planet. Of course, that speed drops as you get closer to the poles, but it's a constant, powerful motion we share with everything and everyone on Earth. The atmosphere moves with us, the oceans move with us, so we're cradled in this motion, totally oblivious to the incredible velocity. This rotation is the smallest gear in our cosmic machine, but it's fundamentally important. It creates the Coriolis effect, influencing weather patterns and ocean currents. It's the reason a day is 24 hours long. But this personal spin is just the beginning. The entire planet is locked in a much larger, much faster dance. This brings us to the second layer, Earth's orbit around the Sun. This is the motion that defines our year and gives us our seasons. We all learned the model in school, the Earth and its siblings tracing neat elliptical paths around a central star. But the numbers behind this familiar picture are staggering. To complete its annual journey, Earth travels at an average speed of about 30 kilometers per second. That's over 107,000 kilometers per hour. Let's try to put that into perspective. The fastest maglev train in the world tops out around 600 kilometers per hour. Earth, in its orbit, is moving more than 178 times faster than that. Every single second you and I travel 30 kilometers through the void. By the time you finish this sentence, you'll be hundreds of kilometers from where you started. We are on an unbelievable cosmic racetrack and we don't feel a thing. Our orbit isn't a perfect circle, it's a slight ellipse. This means our distance from the Sun changes. At our closest point, perihelion, we're about 147 million kilometers away. At our farthest, aphelion, we're about 152 million kilometers out. This orbital path lies on a specific plane, a flat sheet of space known as the ecliptic plane. Think of the solar system as a spinning vinyl record. The planets are like tiny specks in the grooves, all orbiting on this relatively flat surface. For centuries, this was seen as the peak of cosmic motion. Humanity saw a clockwork universe with planets orbiting the Sun in a predictable, stable system. It was believed that the Sun, our magnificent star, was the stationary center of it all, the great unmoving anchor. But this is where the story really opens up. This is where we have to leap from the solar system to the galaxy. Because the sun isn't sitting still, it is not an anchor. It's a star on a journey of its own, and it's taking all of us with it. The familiar dance of Earth around the sun is just the first step. That flat, orderly plane is about to be revealed as something else entirely, the spiraling path of a system in flight. For most of history, we pictured our solar system as a static object, but that model is fundamentally incomplete. It's like describing a person walking down the aisle of a speeding train without ever mentioning the train itself. The sun, our anchor, is that train, and it's moving at a speed that dwarfs everything we've talked about so far. Welcome to the third layer of our motion, the solar system's grand orbit around the center of the Milky Way, our entire home, the sun, Earth, Jupiter, all the planets, asteroids, and comets, is hurtling through the galaxy at an average speed of about 220 kilometers per second. That's a mind-numbing 792,000 kilometers per hour. At that speed, you could zip around Earth's equator in under 3 minutes. So where are we going? We're in orbit. Just as Earth orbits the sun orbits the gargantuan center of the Milky Way. Our galaxy is a colossal barred spiral, a swirling city of hundreds of billions of stars. At its heart lies a monster, a supermassive black hole named Sagittarius A, a gravitational titan with the mass of over 4 million suns. It's this immense anchor, along with the combined mass of all the stars and dark matter, that our sun is bound to. We live about 27,000 light-years from that chaotic core, nestled in a minor spur of stars called the Orion Arm. We are essentially cosmic suburbanites. This galactic journey is so vast it takes our solar system about 225 to 250 million years to complete just one single orbit. This span of time is called a galactic year. Let that sink in. The last time our solar system was in this same spot in the galaxy, the very first dinosaurs were just starting to evolve. The continents were fused together into Pangaea. In its 4.5 billion year lifetime, our sun has only completed about 18 to 20 of these galactic laps. Modern humans have been around for a tiny fraction of 1% of a single galactic year. Now let's talk about a popular idea you might have seen online, the helical model. Those animations showing the solar system as a vortex, with the sun plowing through space and the planets spiraling behind it. This image is both powerful and a little misleading. The truth is more elegant. The planets do trace a helical or corkscrew path through the galaxy. As our sun speeds along its orbit, the planets are continuously circling it. The combination of the sun's forward motion and the planet's orbital motion creates this beautiful spiral pattern. But many viral videos get a key detail wrong. They often show the plane of our solar system, the ecliptic, as being at a 90-degree angle to the sun's direction of travel, like a boat with planets orbiting its mast. The reality is more intricate. The plane of our solar system is actually tilted at about 60 degrees to the plane of the Milky Way. Think of it like this. If the galaxy is a flat spinning record, our solar system isn't spinning like a top flat on its surface. It's tilted like a spinning coin flicked at an angle across the record. This 60-degree tilt means that as we move through the galaxy, the planets aren't just trailing behind the sun. At certain points in their orbits, planets like Earth can actually be ahead of the sun on its galactic journey. 6 months later, we're trailing it. We're constantly weaving back and forth across the sun's primary path. This replaces the simple vortex model with a more complex and accurate picture of an angled, weaving, corkscrewing journey. We're not just being dragged along, we're part of the spiraling vanguard. This third layer of motion shatters the old static view of the cosmos. Our home isn't a place, but a path, a spiraling trajectory around a city of stars. But even this incredible high-speed galactic race isn't the end of the story. Our path isn't a smooth, flat circle. There's another layer of motion, a cosmic ripple that turns our grand tour into a celestial roller coaster. Our journey through the Milky Way, as epic as it is, isn't a flat one. There's a fourth layer of motion at play, one that pulls us up and down in a gentle, long-period oscillation, like a horse on a cosmic carousel. We're on a galactic roller coaster. As our solar system orbits the galactic center, it doesn't stay perfectly within the galaxy's flat disk. Instead, it bobs up and down, passing through the dense central plane, moving north, then being pulled back down by gravity, passing through again and moving south. What causes this galactic bounce? Simple: gravity. The Milky Way's disk is packed with stars, gas, and dust. This concentration of mass has a powerful pull. As our momentum carries us above the plane, the combined gravity of the disk below acts like a giant safety net, slowing our ascent and pulling us back down. We accelerate, pass through the dense mid-plane, and our momentum carries us out the other side. Then the gravity of the disk, now above us, pulls us back up. The result is a perpetual, gentle bobbing motion. This up and down journey is not quick. It takes 60 to 70 million years to complete one full oscillation. This means we pass through the crowded galactic plane roughly every 30 to 35 million years. Right now, astronomers have figured out we're about 50 to 80 light years above the midplane and still heading up. We last crossed the plane a few million years ago and will reach our peak height in about 14 million years, before beginning the long, slow fall back toward the galactic heartland. This might seem like a minor detail, but some scientists believe it could have profound consequences for Earth. The galactic plane is the most crowded part of the galaxy. A fascinating, though controversial theory known as the Shiva hypothesis suggests that when our solar system passes through this dense region, it's at a higher risk of gravitational disturbances. The idea is that the gravity from nearby gas clouds could jostle the Oort cloud, the vast shell of comets surrounding our solar system, sending a shower of them toward us, leading to a spike in devastating impacts. Some researchers have even tried to link Earth's major mass extinctions to this 30 million year cycle. The evidence is heavily debated and far from certain, but the possibility is chilling. It suggests our journey isn't just through space, but through regions of varying cosmic danger. Whether that theory holds up or not, this fourth layer adds a beautiful wave-like dimension to our path. We're not just corkscrewing in a flat plane. We're a corkscrew on a wave, spiraling and oscillating as we lap the galaxy. So we have four motions: Earth's daily spin, its yearly orbit, the solar system's galactic race, and our vertical bobbing. But we have to zoom out one more time, because the Milky Way itself, our entire home, is not stationary. Our whole city of stars is on a journey of its own, hurtling towards an unavoidable, colossal encounter. We've traced our motion from our planet to our star, and from our star to the edges of our galaxy. Now we take the final leaps, zooming out to see our galaxy as just one traveler in a vast intergalactic caravan. This is the fifth layer of our motion, the journey of the Milky Way itself. Our galaxy isn't an island. It's a leading member of a gravitationally bound collection of over 50 galaxies called the Local Group. Most of these are small dwarf galaxies, but there are two undisputed heavyweights: our own Milky Way and the magnificent Andromeda galaxy. Andromeda is our closest major galactic neighbor, about 2.5 million light-years away. It's slightly larger than the Milky Way and is the most distant object you can see with your naked eye. And for as long as we've been able to measure it, we've known it's getting closer, much closer. Astronomers have confirmed that Andromeda is hurtling towards us at about 110 kilometers per second, or nearly 400,000 kilometers per hour. This isn't a near miss. Precise measurements from the Hubble Space Telescope have confirmed we are on a direct collision course. In about 4.5 billion years, our galaxy and Andromeda will begin a slow, spectacular, and transformative merger. The future event is sometimes called Milkomeda. What will this collision look like? The word is misleading. A galaxy is mostly empty space. The distance between stars is so vast that when they merge, direct star-on-star collisions will be almost zero. A star system like ours has a very high probability of coming through just fine, but the galaxies themselves will be completely reshaped. Immense gravitational forces will stretch and distort their beautiful spiral arms, flinging long streamers of stars and gas into space. The night sky, as seen from Earth, will be breathtaking. For millions of years, Andromeda will grow larger and larger in the sky, eventually filling our entire view. The sky will be ablaze with the light of two galaxies intermingling, triggering a massive burst of new star formation. After a dance lasting billions of years, the two will settle into one single, gigantic, elliptical-shaped galaxy. The two supermassive black holes at their centers will eventually spiral into one another to form an even more massive one at the heart of the new Milkomeda galaxy. This grand merger is our destiny. But even this motion, this 110 kilometer per second rush toward Andromeda, isn't the full picture. There's something else going on. The entire local group, our whole caravan of galaxies, is being pulled in a single direction by a force so massive it has one of the most evocative names in astronomy. We've now layered 5 distinct motions, each one expanding our perspective, yet there's a 6th all-encompassing motion to consider. To see it, we have to zoom out to the scale of superclusters and the very fabric of the universe itself. We must confront the mystery of the greatattractor and the cosmic currents it creates. In the 1970s and 80s, astronomers noticed something strange. They found that thousands of galaxies in our cosmic vicinity, our local group, the nearby Virgo cluster and more, were all streaming in the same direction. This was an extra speed on top of the normal expansion of the universe. The only thing that could cause such a flow is the gravitational pull of a colossal concentration of mass. They named this unseen source the greatattractor. Our entire local group is being pulled toward this mysterious region at a phenomenal speed of about 600 kilometers per second, over 2 million kilometers per hour. The greatattractor isn't a single object, but a vast region of space, a gravitational focal point within the massive Laniakea supercluster, a structure containing 100,000 galaxies of which we are just a tiny part. But the story doesn't end there. The hierarchy of motion continues. The greatattractor is not our final destination, but simply a massive waypoint on a much longer voyage. Just as our solar system is a passenger on the Milky Way's journey, our entire Laniakea supercluster is itself a passenger on an even grander cosmic river, being pulled toward an even larger concentration of mass, the Shapley supercluster. This gravitational titan, located about 650 million light-years away, is one of the most massive and densest superclusters known, containing over 8,000 galaxies. It forms a giant structure that pulls entire clusters, including our own Laniakea supercluster, toward it. This cosmic flow, however, isn't just about being pulled, it's also about being pushed. Scientists have discovered that working in opposition to these massive attractors is a vast, underdense region of space called the dipole repeller. Unlike the greatattractor or Shapley, which pull matter in, the dipole repeller is a cosmic void with very few galaxies. Because it has a much weaker gravitational pull than its dense surroundings, it effectively pushes our local group away. Our motion is therefore a result of a cosmic tug-of-war. We are simultaneously being pulled toward the Shapley supercluster and pushed from behind by the dipole repeller, creating a powerful stream-like flow of galaxies across the cosmos. And even this may not be the end of the chain, as some evidence suggests that the Shapley supercluster itself is being pulled toward another, even more distant structure known as the Sloan Great Wall. This raises a mind-bending question. With all these structures pulling and pushing us, will we ever actually get anywhere? The answer introduces the final and perhaps most profound layer of our motion, the expansion of the universe itself. On local scales, gravity is king. It pulls our local group toward the greatattractor, and it pulls our entire supercluster toward Shapley. But on the vastest scales, there is a competing force, dark energy, which drives the accelerating expansion of space itself. This expansion isn't an explosion of matter through space, but an expansion of space. It's like a universal current carrying everything away from everything else. The universe is not moving through anything because it is everything. There is nothing outside for it to move through. For gravitationally bound structures like our solar system or even our local group, this expansion is negligible. Gravity easily wins. But for the colossal, loosely bound superclusters, it's a cosmic tug-of-war. We are hurtling towards the greatattractor, but the space between us and it is expanding. Even more dramatically, while our Laniakea supercluster is flowing toward the Shapley supercluster, the immense distance means the expansion of the universe is carrying Shapley away from us even faster. We are on a cosmic treadmill, forever running toward a destination we can never reach. Furthermore, recent research suggests the universe might have another motion, a slow, almost imperceptible spin, completing a single rotation over hundreds of billions of years. So what's our final ultimate speed? To answer that, we need a universal frame of reference. We find it in the cosmic microwave background, or CMB, the faint afterglow of the Big Bang. It permeates all of space and is the ultimate rest frame of the universe. Any motion relative to the CMB is our true motion through space-time. When we measure our solar system's velocity against the CMB, accounting for all the nested motions, our orbit, the Sun's galactic orbit, our galaxies fall toward Andromeda, and our superclusters flow toward the greatattractor, we find we are moving at about 370 kilometers per second. That's 1.3 million kilometers per hour toward the constellation Leo. This is it, our net velocity. The result of all the pulls, pushes, orbits, and flows is one final incomprehensible speed in one specific direction. This incredible, multi-layered journey is the reality of our existence. If this trip through the cosmos expanded your perspective, consider liking this video and subscribing for more explorations into the wonders of our universe. Let us know in the comments which layer of motion you found the most mind-bending. So let's go back to where we started, to you sitting still. That feeling of stillness is a beautiful lie, masking a symphony of motion. You're spinning on a planet at supersonic speeds. You're orbiting a star at 30 kilometers every second. You're part of a solar system corkscrewing around the Milky Way at 220 kilometers per second, all while bobbing up and down on a 60 million year cycle. You are inside a galaxy hurtling towards a cosmic collision with Andromeda at 110 kilometers per second. You are part of a galactic group being pushed by the dipole repeller and pulled towards the greatattractor and the even more massive Shapley supercluster. And all of this is happening inside a universe that is itself expanding and perhaps even spinning. Your net result, your final speed against the backdrop of creation itself, is a staggering 370 kilometers per second. You are not sitting still. You have never been still. You are a passenger on spaceship Earth, engaged in an ancient and intricate dance. Every moment of your life, you are part of one of the most complex and beautiful journeys imaginable. A journey that began billions of years ago and will continue for billions more. The next time you look up at the night sky, remember that you are not just looking out at the universe. You are flying through it. You are a part of its grand, perpetual, and awe-inspiring motion.